This Introduction to Python series is part of the EPSCoR Track 2 DDMD workshop. In this presentation, we'll be talking about Python lists. In Python, there are 4 collection data types. A list is a collection which is ordered and changeable, and it allows duplicate members. A tuple is a collection which is ordered and unchangeable. It also allows duplicate members. A set is a collection which is unordered and unindexed, and no duplicate members are allowed. A dictionary is a collection which is unordered, changeable, and indexed, and again, no duplicate members are allowed. Here we have 2 simple examples of Python lists. Python lists are ordered and changeable. They're written with square brackets, and the elements within the list are separated by commas. Our first example, fruit list, is a list of strings, and the second list, grades, is a list of integers. Items within a list are accessed using their index numbers. So in our fruit list example, we have 3 elements. Apple is at position 0, banana is at position 1, and cherry is at position 2. So their indexes are 0, 1, and 2. If we want to access the second element within the list, which is banana, we access it by using its index. So we say fruit list bracket 1 is bananas. You can specify a range of indices by specifying where to start and where to end the range. When specifying a range, the return value will be a new list with the specified items. So given our example fruit list, we have the items apple, banana, cherry, orange, kiwi, and melon. To retrieve a subset of this list, say we want to start at index 2 and go up to but not including index 5, we would say our short fruit list is assigned fruit list bracket 2 column 5. That will return the sublist cherry, orange, and kiwi. And notice that gives us the elements at index 2, index 3, and index 4. Unlike Python strings that are immutable, items within a Python list can be changed. So to change the value of a specific item in a list, you refer to the index number. So again, we look at our example fruit list, which is assigned apple, banana, cherry, orange, kiwi, and melon. Let's say that we want to change the 4th element in the list from kiwi to strawberry. So we can say fruit list bracket 4 is assigned the value strawberry. Then we look at the list and our items are now apple, banana, cherry, orange, strawberry, and melon. Leveraging a for loop, we can easily access each individual item within a list. So in our example, our fruit list is assigned the values apple, banana, cherry, orange, kiwi, and melon. If we want to access each one of those items within the list individually, we can loop through that list using a for loop, assigning the variable fruit each item one by one until each item in the list has been accessed. So we have for fruit in fruit list, print the fruit. Python allows us to easily determine if a specified item is present in a list using the keyword in. So again, we have our fruit list, apple, banana, cherry, orange, kiwi, and melon. We can ask the question, is orange in our list, by saying if the string orange in fruit list. That's either true or false. If it's true, it's going to print yes, orange is in the fruit list. If it's false, there won't be any output. Using the built-in length function, len, we can determine how many items are in our list. So in our example, we initialize fruit list, and then we can determine the number of elements in fruit list by calling the length function, len, with the fruit list as a parameter. This function will return the number of items in the list. And so you can see that we print out the number of items in fruit list is 6. One of the ways that we can add an item to the end of a list is by using the lists append method. So in our fruit list example, we want to add peach to the end of the list. To do that, we say fruit list dot append, and we use the string peach as a parameter. You can see when we print the list that peach has been added as an element to the end of the list. We can add elements to a list at a specific location by using the lists insert method. So in our example, again, we have our fruit list, and we want to insert peach at index 1, which would make it the second element in the list. So you can see when we print the list, peach has been added as the second element. We can remove elements from our list by using the list remove method. So you can see in our example, again, we have our fruit list. We want to remove cherry. So we say fruit list.remove, and we use cherry as the parameter. And when we print out our list, cherry no longer is an item in our list. The pop method is another method that we can use to remove elements from the list. Given the pop method, it has an optional parameter index. If the index is specified, pop will remove the item at that specified index. If the index is not specified, the method removes the last element. So given our fruit list, if we call the method pop, notice that it removes the last element in the list, which is melon. Here's an example where we call the pop method with a specific index number. So we have our fruit list, and now we want to pop the element at index 2, which is cherry, or the third position in the list. So we call the pop method and we print out our list, and we see that cherry is no longer in the list. The built-in delete function, del, is yet another way that we can remove elements from our list. So in our example, we start with our fruit list. We call the function del, specifying fruit list and element 2. So again, we're going to delete cherry from our list, and we print the list, and cherry is no longer an item in the list. So we've talked about the remove and pop methods and the built-in delete function. How do these differ? Well, the remove deletes the matching element object, whereas delete and pop removes the element of specific index. So recall when we called the remove method, we gave a specific element like remove cherry or remove apple. So we specified the element that we want to delete. With delete and pop, they deal with the index. The only difference between pop and delete is that pop returns the value that it popped out of the list, where delete does not return anything. Pop is the only way that we can return an object. Remove is the only one where we can actually specify a specific object. Here we provide an example of using the POP method to remove an item at a specified index in a list and return that item. We have our fruit list: apple, banana, cherry, orange, kiwi, melon, and we're going to pop the item at index 2, which is the third element of the list, and we're going to return it and assign it to the variable a fruit. So after the pop method has been called, we print our fruit list, and cherry is no longer an item in the list, and a fruit is assigned the value cherry. To remove all of the elements in a list, we call the clear method for that list. So in our example, we have our fruit list, then we call the clear method. When we print our list, we see that it's the empty list. When you want to make a copy of a list, you can't copy a list simply by typing, for example, list 2 is assigned list 1. That's sometimes referred to as a shallow copy. List 2 will only be of reference to list 1. So any changes you make to list 1 will automatically also be made to list 2. Let's look at a more detailed example of a shallow copy. So we have list 1, and we're going to assign it the values apple, banana, cherry, orange, and kiwi. Then we're going to make the assignment statement. List 2 is assigned list 1. In this example, you can see that list 1 and list 2 are both referencing the same list. So when I call the method remove orange from list 1, it's also going to affect what list 2 represents. So you can see remove orange, and if I print list 1, I get apple, banana, cherry, kiwi, and if I print list 2, I get apple, banana, cherry, kiwi. And that's specifically because list 1 and list 2 variables are pointing to the same list. This example illustrates the copy method, where we see that list 1 represents a list, apple, banana, cherry, orange, and kiwi. When we assign list 2 a copy of list 1, calling the copy method, the Python interpreter creates a distinctively new list, and in this list it assigns all the elements that were in list 1, and then that variable or that list is assigned to list 2. To create a copy of a list, we use the copy method. This will create a new list containing the same elements as the list we're copying. So list 1, we have apple, banana, cherry, orange, and kiwi. Then we assign list 2 list1.copy. So we're making a new list that's a copy of list 1. So now when we remove an element from list 1, we remove orange, we print out list 1, and it's apple, banana, cherry, kiwi, missing orange, but list 2 is still the copy that we made before the remove method, and it does still contain the element cherry. This is referred to as a deep copy. Another way we can make a copy of a list is by using the built-in list function. So in this example, we have list 1, and then if we want to make a copy of list 1, we call the built-in function list, and we use list 1 as a parameter. The Python interpreter creates a new list and assigns it all the elements that are in list 1, and then that list is assigned to the variable list 2. And then again, if we test it by removing an element in list 1, we print list 1, orange is missing, but we print list 2, and orange is still an element of list 2. This again is an example of a deep copy. There are several ways to join two lists. One of the easiest ways is using the plus operator. Here's an example of joining two lists using the plus operator. List 1 contains the elements A, B, C. List 2 contains the integers 1, 2, 3. Then we can assign a new list, list 3, the values in list 1 plus the values of list 2. Therefore, list 3 has the elements A, B, C, 1, 2, 3. And take note that in a list, we can have a mix of data types. So in this example, we have 3 strings and we have 3 integers. Another way to join two lists is by calling the list append method. So in this example, list 1 has the values A, B, C. List 2 has the integers 1, 2, 3. Then we can loop through all the elements in list 2 and append those elements one by one to list 1. So in this for loop, the first time through the loop, or the first iteration, X is assigned the value 1. 1 is appended to the back of list 1. Then X is assigned list 2. 2 is appended to the back of list 1. And lastly, X is assigned the value 3, and it's appended to the back of list 1. When we print list 1, we have A, B, C, 1, 2, 3. You can use the extend method, which purpose is to add elements from one list to another list. So again, we have list 1 has the elements A, B, C. List 2 has the elements 1, 2, 3. We can extend list 1 by calling the extend method and having list 2 as a parameter. The Python interpreter will take all the elements in list 2 and add them to list 1 and extend the size of list 1. List 1 becomes A, B, C, 1, 2, 3. We can easily create a list from a string by using the built-in list function. So in our example, we have a string and we assign it the value Lushbow. Then to create a list from that string, we call the built-in function list and use string 1 as a parameter. The results of this function call are assigned to the variable string list. So now string list is a list of characters. In this example, we assigned string 1 the string Lushbow. Then we created a list using string 1. And we print string list, and we have a list of characters that are the characters in string 1. Notice that we can change any character in our string list. So let's modify string list 1 to an uppercase U. And we print string list, and we see that the U has been modified to an uppercase. If we try to do the same thing with our string 1, we try to change the first character in our string, we generate an error. And this is just emphasizing that strings are immutable. So we can change elements within a list, but we cannot directly change characters within a string. When we call the split method on a string, it actually returns a list. In this example, sentence is assigned the string Python is a great programming language. We call the split method on sentence, and we're splitting by the substring a blank. And that returns a list, and we're assigning it to the variable word list. When we print out word list, you can see that we have a list of substrings. So we have Python is a great programming language. We can call the sort method on that list. And so when we sort word list and then we print out word list, you can see that it's sorted by alphabetical order. Here's another example of calling the sort method on a list. So in this example, we have a list of grades. Then we sort grades and we print out grades, and you can see by default the grades are sorted in ascending order. To sort a list in descending order, we must specify the parameter reverse equals true. So in this example, we have our grades list and we sort it with the parameter reverse equals true, and you can see that the grades are now sorted in descending order. The list method reverse is used to reverse the elements in a list. In this example, we have our grades. Then we call the reverse method on our grades, and you can see that now the grades in the list have been reversed. Python provides two built-in functions, min and max, that allows us to determine the minimum and the maximum element within a list. In this example, we have our grades list. We can use the built-in max function, passing in grades as a parameter, and it will return the highest value within that list. We can use the built-in min function, pass in our grades list, and it will return the minimum value in the list. When we print them out in this example, we can see that the highest value is 99 and the lowest value is 67. The list method count allows us to count the number of times an item appears in a list. In this example, we have grades A, B, A, C, A. If we want to count the number of A's in the list, we can call grades.count and use the string A as a parameter. This method will return the number of A's in the list, and in this example, you can see that it prints out the number of A's is 4. This table displays the list methods that are available along with a brief description. Let's develop a Python program that'll calculate the mean, median, and range of a list of grades read in from a text file. Just recall that the mean is the average, the median is the middle value. So first the list will need to be sorted. If the number of values in the list is even, the median is the average of the middle two values, and the range is defined as the difference between the largest and the smallest value. The steps involved in calculating the mean, median, and range of a group of grades will involve opening a file, reading the grades into a list, sorting that list, determining the median grade, which is the middle grade, and if the number of grades in the list is even, then we need to find the average of the middle two grades. Then we're going to calculate the range, and we're going to calculate the mean. So let's first consider opening the grade file and reading the grades into the list. In this code segment, we first open a file called grades.txt, which is in the input files subfolder. This code segment assumes that this grades.txt file consists of values representing grades, where each value is on a separate line. Once the file is open, we next initialize grade list to the empty list. So an empty list is represented by square brackets with nothing within the brackets. And these square brackets are assigned to the variable grade list. We use a for loop to process each line in our grades file. So for each line in the file, we strip off the new line feed. We convert the line to an int and we assign that value to a variable grade. Then we append that grade to our grade list, and we do this for each line in our file. On the completion of the for loop, we have a list called grade list, and this grade list consists of a list of integers representing grades that were read in from the grades.txt file. Once we've read our grades into our grade list, we're going to sort the list, we're going to find the lowest grade, and we're going to find the highest grade. Grade underscore list represents our list of grades. We can use the list sort method to sort that list. And recall that when we sort, it's going to sort them in ascending order. Next, we can assign the highest grade by using the built-in function max and use our grade list as a parameter. And we can assign the variable lowest grade to the minimum grade in the grade list by using the built-in function mingrade. Just to verify that we have found the lowest and highest grade, we can print out that the highest grade is 100 and the lowest grade is 50. Sorting our grade list will help us determine the median grade, which is the position of the middle grade in our list. In this example, we have 9 grades, so the length of our list is 9. To determine the median grade, we want to find the index of that grade. To find the index of that grade, we take the length and we divide it by 2 using integer division. So we find the quotient, which represents the index of the median grade. And in this example, the index is 4, so our median grade is 85. If our sorted list of grades has an even number of elements, to determine the median grade, we need to average the middle 2 grades. So in this example, we have 10 grades. To determine the middle 2 grades, the middle item 1 is the length, and in this example 10, div 2, which is equal to 5. The second middle item is equal to the length div 2 minus 1. So the indexes of the middle 2 items are 5 and 4. So we want to average those 2 grades. So we take the 85 and we add it to an 82 and divide it by 2. Reviewing our algorithm, we've opened our file, we've read in our grades, we've sorted our list, we've determined the lowest grade, we've determined the highest grade. Now we're going to determine the median grade, and we're going to determine the range, which is the difference of the lowest and the highest values. Here's our Python code segment that shows how we would determine the median grades. First, we find the length of the grades using the built-in length function and our grade list as parameters. Next, we determine whether or not the length of our grades is even. So if the length of grades mod 2 is equal to 0, that means it's an even number of grades. We find grade 1, which is grade list, with an index of the length of grades div 2. The second grade is grade list with an index of length of grade div 2 minus 1. Then we can calculate the median grade by adding grade 1 and grade 2 together and dividing it by 2. If the length of the grades is an odd number, so length of grade mod 2 is not equal to 0, the else is executed, and our median grade is just simply the middle grade, and the middle grade is grade list, length of grade div 2. Once we find the median, now we can find the range, and the range is the highest grade minus the lowest grade. And in this example, we see that the highest grade is 100, the lowest grade is 50, the median grade is 78, and the range is 50. Lastly, we want to calculate the mean or the average of the grades. Python provides a built-in sum function that allows us to use a list as a parameter, and it'll return the sum of the values within that list. So in this code segment, we're going to find the sum of the grades in grade list and assign that to our variable grade sum. Then we're going to calculate the average of the grades by dividing the grade sum by the length of the grade list, and that will give us our average grade. Here's an example of our final Python program for processing our grades. So again, we open our file, we initialize our grade list to the empty list, we read in our grades from our grade file, one line at a time. We sort our grades. We use the built-in max and min functions to determine the highest and the lowest grades. Then we find the median grade by determining the length of the grades and determining if the length of the grades is even or odd. So if the length of the grades mod 2 is equal to 0, so there's an even number of grades, we average the middle two grades. Otherwise, we just access the middle grade. Then we determine the range of our grades by subtracting the lowest grade from the highest grade. And lastly, we calculate the average by using the built-in sum function to sum all of our grades and divide the sum of our grades by the length of our grade list. Importantly, we use a try except block, and there's two different errors we're guarding against. If our file of grades happens to be empty, or we run across a line in our file that doesn't represent a valid grade, the Python interpreter will throw a value error. So we need to catch that error. And secondly, if the file is empty, we would have a zero division error. So we have blocked our code with our try except to guard against those errors. One other note before we leave our grade example. What if we want to know if anyone got 100% or their grade is 100%? So we can say that a perfect score is equal to 100. And then we can count the number of occurrences of 100 in our grade list by using the list count method and specifying perfect score is the value that we're wanting to count. So in this code, we set perfect score equal to 100. Then we call the count method gradelist.count, and we pass in 100 as our parameter. And this is going to return the number of times 100 occurs in our list. So if count is greater than 0, we can print the message, yes, there were 3 perfect scores. If count is not equal to 0, that means that 100 did not appear in our list, and we can print out the message, there are no perfect scores.